Python, like life, can be full of surprises. Ever look at code and wonder what's happening? You stare at it, completely lost. You look at this and think, what's the catch? Usually, it's because the fundamentals aren't quite clicking yet, but mastering the basics is your ultimate key to success. Take the copy method. It creates a true physical duplicate of your data. When you use it on a list, it grabs every item and creates what we call a hard copy. Running this, you'll see that in our original list, which we're printing now. Jamie, Robert, and Susan are all there, but look at the copy list. Only Robert and Susan remain. In this version, Jamie has been removed. This is a completely separate physical copy. It is not just a reference to the original. If you remove the copy method, both variables point to the same data. Now, when you delete Jamie, you'll notice he vanishes from both the old list and the new one. So, looking at this next block, the list constructor, what's the goal here? What do you think happens to the original when we remove Jamie now? Surprise, Jamie is missing only from the new copy list. This happens because the list constructor in Python accepts a list and automatically generates a physical copy for you. Instead of manually calling the copy method like before, the constructor handles that duplication behind the scenes. So why use the constructor at all? Doesn't it seem a bit redundant? It can be confusing. The copy method shows much clearer intent. Usually you want your code to scream exactly what it's doing. I want to copy this. Using the constructor here looks like converting a list into a list. It's a bit odd, but stick with me. It works. And there's a huge benefit to this. What do you see in this next example? The same names, but look closer. This time we're using a tuple. Tuples are wrapped in these round brackets instead of square ones. We're using that same list constructor to process our users and remove Jamie. Taking Jamie out leaves Robert and Susan. Now, watch the magic happen. The original users list still has Jamie, Robert, and Susan, but our new copy has only Robert and Susan. It didn't just copy, it transformed. It converted a tuple into a list and created a hard copy at the same time. You can already see why this is powerful. The list constructor can take many different data types and turn them into lists while keeping the original safe. You might wonder, can't I just use the copy method on a tuple? Actually, no. Tuples don't have a copy method. If you try it, your code will crash. Tuple object has no attribute copy. The method simply doesn't exist there. That's why this constructor is so versatile. It allows us to duplicate and convert data in one clean step. This is a game changer when you're pulling varied data types from all across the web using different APIs.